Moving past the exponents, 8.4 is about polynomials and kind of an introduction to what polynomials are and all that good stuff. So let's start with a definition first so we understand it. A polynomial, if you break it down into its parts, poly means many, and nomial is like names, many names, all right? But really the key piece you want to get here is the many part. So a polynomial, the definition, is a monomial or the sum of monomials. And technically, it's the sum or difference. So it could be adding or subtraction. Okay, the sum or difference of monomials. And we're going to come back to that in one moment. Once I explain the monomial, we'll talk about it again. But here we have a little chart, and here are some monomials. 7 is a monomial, 2n is a monomial, or 4ab cubed c squared. All right, we spent a section where we talked about what a monomial was. All right. A polynomial is basically the overall name of what all of these are. Okay, so like I said, we'll get back to that in 1 second. These are examples of binomials. So a monomial has one term. A binomial has two terms. And the terms are separated by addition or subtraction. That's where the sum or the difference comes in. So there's one term here and one term here. The addition is what breaks it. So that's two terms. This is two terms, 1, 2. This is two terms, 1, 2. So it's the addition or subtraction that breaks it up. The trinomial, like a triangle, is 3 terms. And again, the addition or subtraction breaks it up. So there's 1, 2, 3, 1, 2, 3, 1, 2, 3. 3 terms, all right? So a polynomial, let's actually add that down here. A polynomial would be something that has 4 or more terms, right? Because it's many terms, all right? So that's actually would be the next one in the chart, but we have it up here. So for example, 2x cubed plus 5x squared plus 3x plus 7. And any of those could be subtraction too, but 1, 2, 3 breaks, which creates 1, 2, 3, 4 terms, or 5 terms, or 10 terms, or 50 terms, whatever. If it's got 4 or more terms, then it falls into the polynomial category. Now the crazy thing about it is that all of these are considered polynomials. So it has its own category, meaning 4 or more, but all of these actually fit into a proper category. It's kind of like country and country. I live out in the country. I live in a different country. So if you live out in the country and you have on a farm, let's say, you still live in this country. So it's kind of like a category within a category. So it can be a little confusing, but just you try to remember that a polynomial would have 4 or more terms, but technically all of these things are considered polynomials, okay? So if you want to find the degree of a polynomial, this is very simple. The degree, I'll give you some examples and then you see if you can figure it out. The degree in this one is 0. The degree in this term is 1. And the degree in this one is 3. Have we figured it out yet? All right. Let's look at this one. The degree of this polynomial is 1. The degree in this one is 2. And the degree in this one is 2. Where are those numbers coming from? All right, let me give you an example, or let me give you the answer. The degree is simply the largest exponent in a polynomial. So there is no variable here. So this is on a variable. Let's write that. That's important. So there's no variable here. So if I had to write it in, I'd have to write x to the 0 power because it's really not there at all. So that's why the degree is 0. The n has no exponent, but it's understood to be 1. So that's why that's 1. And then if there is an exponent, then it's easy to see why that's 3. Neither of these have exponents, but this one would be y to the first. So that's 1, x to the second, and r to the second, that's the second. So what would these three be? This one would be 1. This one would be 4. And what would this one be? It would be 3. Okay? Very, very simple to identify the degree, the largest exponent. Arranging, very simple also. We're going to arrange the polynomials so the powers of x are in descending order. That means they go down. So you want your highest x first. So this term is all going to move together. That's got the highest exponent, so that starts. Then the second one is this guy. And he doesn't have a sign in front, but he's understood to be positive, so we put him here. And then the negative 11 has no x's on it, so it's last. So you're just rearranging these three terms, because this is a trinomial, 3 terms, in a different order. So you want to make sure you always carry the sign with it. The sign that's in front of it goes with it. So when we look at 2, you have to remember we're focusing on the x. So which one has the highest exponent on an x? Be this guy right here, 5x to the third. He's gone. Then x, no x, x to the second. That's going to come next. And this all travels together as a single term. You don't break it apart. This guy goes all together as 1. This guy goes all together as 1. Then this one's going to be the next one, and it has an x on it, just a plain old x. And the sign is understood to be positive. And then this guy has no x at all, so he's last. So that's descending order. This is very important when we get to second semester or third quarter, fourth quarter, when we're factoring. Everything has to be in descending order, so it's good for us to practice this. The opposite of that would be ascending order, so they're going up. So see if you can put these in the opposite order, where you start from no x's and you go to the highest x. Go ahead and push pause and then see how you do. All right, so if we look at this, the guy that has no x's is 5. So we're actually going to start with the 5. Then this guy's got only 1x, so that's next. Then we have 2 x's. Then we have 3 x's. So you're focusing only on the x's, and you want to make sure you pay attention to the sign in the front of each one and bring it with it. This one in ascending order, we've got a's and x's, so focus on the x's. Some people might find it easier if they actually highlight it. X to the second, x to the fifth, x, and that middle guy has no x at all. So that must mean he's first. So this guy has no x, so we'll start with that one. Then we've got 1x. Make sure you bring the entire term, not just the x, but the whole thing. Then we got 2 x's, so that's this entire term. And 5 x's. Ascending order, going up, like when you accelerate. Trying to think. Nope, that doesn't work. So descending, like decelerate, goes down. Ascending, it's going to go up every time.